let's come back to what we have seen in the last lectures. Does this input-output table look familiar? It is the one we have adopted in the last two lectures about conceptual hands-on in Excel. But where did we take it from, and who is the data provider? This table represents a picture of the global economy taken from the Exaiobase dataset, an open access project which provides global multi-regional input-output tables for all the years from 1995 to 2022. This, in particular, refers to 2019. Since Exaiobase tables are disaggregated into 49 regions, each one highlighting commercial transactions among 163 industrial commodities, to provide you with a conceptual example, we parsed the original table and reshaped it by using the functionalities of the Mario platform. What is Mario? Mario, which stands for Multifunctional Analysis of Regions through Input-Output, is an open-source platform written in Python language useful for handling any kind of input-output tables and models. Mario has its online documentation. The link is in the attached materials to this video lecture. Mario was developed in 2021 by the Sesam Research Group at Politecnico di Milano and can handle the majority of the most diffused open access databases, such as Exaiobase, Eora, and the Eurostat ones, with dedicated parsing functions, as well as customized tables in the shape of Excel, text, or CSV formats. Moreover, it can handle both single and multi-regional tables, monetary or hybrid, and symmetric or supply-and-use tables. In other words, we like to refer to Mario as the ship which any input-output modeler can use to navigate into an input-output data lake. The next two lectures will focus on the solution of the same exercises we already solved in the Excel hands-on session, but using Mario. Keep in mind, this will be just example to show Mario's functionalities, while it was designed to handle much more complex analysis. Therefore, the first step consists into installing Mario on your PC. By navigating to Mario online documentation, you can get the download and installation guide by clicking on the left side menu, as highlighted in red. Here you will find all the requirements you need to get Mario installed. Aside from being in love with input-output analysis, you need to have Python programming language installed, with version 3.7 or higher. The easiest way we recommend is to use the free Conda package manager coming along with Anaconda Python distribution. All the remaining requirements will be automatically downloaded during the installation process. At this point, you just need to open a terminal. If you are using Anaconda distribution for Python, open the Anaconda prompt and follow these three simple steps. It is recommended to create a new Python environment called Mario by running this first string. Once the environment is created, you should activate it by typing and running conda activate Mario. Lastly, you need to run pip install MarioPy to get Mario and all its minimum requirements installed automatically. Please note that some optional packages required for advanced functionalities will not be downloaded in this phase. In case of any issue, do not hesitate to get in contact with us via our dedicated Gitter chat. The link to that can be found in the home page of Mario online documentation. Let's conclude this lecture by getting ready for the Mario hands-on session. The first step is to download the desired Exaiobase table from its Zenodo repository. By scrolling down, you can find and download the correct input-output product-by-product table, referred to here 2019. Once it is downloaded, you can save the zip file into any directory of your PC. For this session, I saved it into a dedicated folder on my desktop called Mario Hands-On Session. In order to start getting your hands on Mario, you should start your Python editor. For this session, I will use Spider. We can start by saving a new script. I will call it Mario Exercise 1, so I will use it also for the next lecture. I will save it in the same directory where I saved the database. Now we can start by importing Mario and by providing the path of the database file. Since it is in the same directory of the script, I will locate my editor into such directory and name a string variable path after the name of the file itself. Now we can create another variable word, which will be our Mario object by typing word equal to mario.parseExaiobase3 and run this first cell. It could take a couple of minutes. Finally, it is possible to check the properties of our object by typing word in the console. As you can see, this is the full original Excirebase table with 49 regions and 200 commodities. In the next lecture, we will aggregate the table and perform the first exercise.